Alright, we're going to do a review of the periodic table, and I'm going to try and keep this to 5 minutes, so I'm going to kind of get started real quick and move quickly. One of the first things to remember is, what is the name of these rows and columns? So what is this vertical column called? And that is, oops, let me get a color here. That is a group. The up and down is called a group. And then for the side to side, what is that called? It's called a period. So this is period 1, period 2, period 3. This is group 1, group 2, group 3, group 4. In periods, we actually don't have that much that we need to remember about them, but groups, we do have a lot to remember there. And the reason is that groups are very similar to each other. And so this is one thing to remember, is that groups, all atoms in the same group react similarly and have similar properties. So that's kind of a fact to have memorized. And do you remember the reason for that? Why do those groups have similar properties and react similarly? The answer is they all have the same valence electrons. This has 1 valence electron, 2 valence electron, 3, 4, 5, 6, 7, 8. And so valence electrons are very important for properties and reactivity. Let's actually start here at 8. This group, what's this group called? This is the noble gases. And I'm going to draw a Lewis structure of one of these. Let's do neon. As you can see, it has 8 valence electrons. What's 8 valence electrons called? What's it called when that's a full shell there? This is an octet. And so noble gases, they have a full octet, so they are very unreactive. So I'm going to write that here, unreactive. I'm going to switch colors for the next group over. This group 17 right here, do you remember the name of that one? These are called the halogens. And the halogens, let's take a look at their Lewis dot structure. Theirs is almost full. So what does that mean about the reactivity of halogens? So because they want to fill up this very last, I'm going to put an X there for it, that X right there, they want to fill that last electron, they're going to be very reactive. So they want to just steal 1 electron from anybody. And then these groups here, 16, 15, 14, 13, we don't actually have that many facts about that. So the next one I'm going to get to are the transition metals. Oops. And so that's all of these right here. Oops. And what we want to know about them is these are the metals you always think of when you hear metal. So they are hard, high melting points, meaning it takes a lot of heat to melt them. And last one, they conduct electricity. Alright, moving down to these last two, what is the name of this group right here? 2. Group 2. These are the alkaline earth metals. And if you look at calcium here with its 2 valence electrons, what do you think that calcium wants to do with those 2 electrons? Well, if the idea is that it always wants to get an octet, like these noble gases, calcium wants to get rid of those 2 valence electrons. And so it's pretty reactive. However, hopefully you remember this because we did some demonstrations with it, the alkaline earth metals are not nearly as reactive as the alkali metals. So let's take a look at sodium, because you've seen sodium in water before. sodium really wants to get away from this one electron. It wants to give it away. So this is very, very reactive. And if you think about it, it has one valence electron. What group on the periodic table wants just one more valence electron? Well, these halogens do. So alkali metals are very reactive with halogens because they want to fill up that one valence electron right there. Another thing to keep in mind about these two groups of metals is that these are both soft and shiny. You can cut both of these with a knife, like a plastic knife. Okay, so the last thing that we want to talk about before we're finished here, so I'm going to zoom out, is some trends here. And the first one I'm going to go with is electronegativity. And so I'm going to write that up here. Electronegativity. And hopefully you remember that this is attracting electrons. And this makes sense because the halogens right here, do they want to attract electrons or give them away? Halogens want to attract electrons. They want to fill up that last little bit. And alkali metals want to give them away. They want to give away that electron. So electronegativity increases in this direction. And then it also increases up here. So the most electronegative, oops, let me undo that. Most electronegative atoms on the periodic table are up in this corner. And the trend that goes right along with that is, shoot, I'm blanking on it right now. Let me take a second to think about that. But the opposite trend, the one that goes down into this corner, this is atomic radii. So think about radius of a circle. It's basically how big is the atom. And the one that I was blanking on there for a second was ionization energy. Ionization energy is the ability or the energy needed. Let me change that. The energy to lose an electron. That makes sense with these two going together because electronegativity increases to this top corner, meaning that they want to hold on to their electrons. So obviously it's going to take more energy to lose an electron if you're up here. Remember that this group right here, that the noble gases, they do not really follow this electronegativity trend because they don't really react with anything. So they're not going to be attracting electrons from anything because they don't want to react. Alright, let's see if I made my 5 minutes. Not quite, but I was close.